Okay, so you've seen how you calculate work and how to get how much work is done on 5 problems there. And what I want to do now is talk about a little bit that work is the same thing as energy. We said it's force times distance. Energy then can be expressed in different ways. The way that energy is expressed can be in kinetic energy, the energy of motion. If you're picking up speed, for instance, you're changing velocities. That is one way your work can be put into you. You change from one mass times velocity squared into another, that you could use that as how much your work going into speeds you up. If you pour energy into something and you want to lift something up, okay, if you have 7,000 joules and you want to have an object be now 1,000 joules in a higher energy position, it's mass times gravity times the height. If you want to compress a spring, if you want to put 1,000 joules in there, then you're going to have to get a half times the spring constant, how stiff that is to compress every meter. If it's a 500 newtons just to compress it halfway, you'll use up your energy pretty quickly by compressing that spring, and then you take it times the distance from normal, from relaxed, that you are squared. All of those can be set equal to each other, and we can do problems that way if you want to change from one type of work to the other. Okay, so that's what this expression is. Work can cause more kinetic energy. You can take and exchange some kinetic energy and put it into the place of potential energy, or your potential energy can land and compress a spring. But these are all those 3 formulas that can set equal to each other those conditions. I think I have enough time on the battery here to set this up, but why don't I stop it and plug in first.